Hi there, this is Dr. John, your physics and math professor, coming to you with another circular motion problem. Here we have an airplane that is making a curve in the air with a radius of 3,282 meters. It's going to take the plane 2 minutes to completely go around a circle of the curve. And what we want to know is, what is the centripetal acceleration of the airplane? So we've talked about this before in a number of different videos. If you're going to be going around, you're going to have a velocity here. So whatever the velocity is at any one point, let's say your velocity right here is that, then later on your velocity right here is that, the magnitude of the velocity of the plane stays the same, but the direction of the velocity changes. So notice if the direction, let's say it starts off like this over here, and then it has to move a little bit. So you want to put a little acceleration like that, so it changes like that, little acceleration like that. Notice the acceleration here is always toward the center. So the acceleration here is always, you have to create an acceleration toward the center to make a plane go around. The velocity is constant. The higher the velocity you would expect, the higher the acceleration you're going to need toward the center to make a plane go around like that. To make anything go around, a car go around a curve, plane go around in the air as well. But this acceleration here, which we call the centripetal, the acceleration centripetal, just like I wrote out there, is toward the center, but it is not an actual acceleration. It's not an actual force. So the force, the centripetal force, would be the mass times the acceleration centripetal. We don't know the mass of the plane, so we don't really care about this. I just wrote this in there so that you know what that is. And we've done this in previous examples. We've said that for something going around a circle, the centripetal acceleration is going to be v squared over r, where r is the radius of curvature. That would be this radius right here, from here to here, r. I drew this in here as the plane goes around, and the velocity is the velocity of the plane at any point here in this straightforward direction. It's an instantaneous velocity, and it constantly changes directors. Remember, velocity is a vector. The direction of the velocity constantly changes, but the magnitude, we're just concerned about the magnitude. And you can also see that because you're squaring it. So any direction sort of gets lost when you square it. So here we have this centripetal or centripetal, if you think of pedaling a bicycle toward the center, if that helps you. This acceleration is actually something that something else causes. It's not a real acceleration. It's something somebody else has to cause. So if a car goes around the curve, the tires have to pull the car toward the center, or the bank of the curve have to make the car go toward the center. If you have a slingshot you're whirring above your head on a string, then that tension in the string has to constantly pull the rock toward you or toward the center of the radius. In the same way here, this airplane, the passengers inside this and the airplane will actually feel an outward force like this. They'll feel like they're constantly be pushed outward. If you've ever been in a plane or a car, you realize when you go around a curve, you get pushed around to the side here. And that force is called the centrifugal force, in that it's like a centrifuge. A centrifuge spins things around like medical samples and stuff in vials and separates things because of extremely high spin velocities, because this centrifugal force, as something goes around, creates an outward force. That's like a force of gravity. It's actually a real gravity. According to Einstein, gravity caused by acceleration, this inward acceleration, gravity caused by acceleration, if you're going up in an elevator, you feel like you're heavier. That kind of gravity is the same as the gravity caused by the mass of the Earth. It's the same thing exactly. So this centripetal, this acceleration toward the center that you must have, causes this outward centrifugal force, which feels like a force of gravity. The passengers in the plane are pushed outward. So something, I mentioned that the acceleration centripetal is not a real thing. It's the effect of something else. Something has to cause this. What is it that causes this? Well, the airplane actually tilts, and when the airplane tilts, the force of the wind and the vacuum on top of the wings actually pulls it upward. So when the airplane tilts, it actually gets pulled upward, much like a car on the bank of a road. It gets pushed upward and inward as well. So it's actually the bank of the plane itself and the shape of the wings that causes this plane to be pulled inward here toward the center, accelerated toward the center. The resultant acceleration can be calculated that way. It's called the centripetal acceleration. We can calculate that, but the cause of this, in this case, is the tilt of the plane itself. So let's erase a couple of things here. I've created a little bit of a mess, and let's start calculating this. So we're told here that the radius of curvature, that is this radius that the plane makes, is 3,282 meters, and it goes around an entire curve like that in 2 minutes. Well, we have the radius of curvature, but we don't have the velocity. We want to find that. Well, if you go around a circle like this, the distance around the circle is equal to, that would be the circumference. The circumference all the way around is 2 pi r. 2 pi times r gets you all the way around. And if you remember, the velocity is going to be equal to the distance you go divided by the time it takes you to go that distance. So if you go all the way around, this is the distance, 2 pi r. So this is going to be equal to 2 pi r. And the time is 2 minutes. Now we don't want it in minutes. We never like it in minutes. We want it in seconds. So this is 120 seconds. So we have this. Let me put this somewhere over here maybe, and we can put the numbers in there. So the velocity here is equal to 2 pi times this, 3282. 3282, like that, divided by 120. I'm coming up with 171.8 meters per second. And notice here we have a bunch of significant figures. Here we have really only one significant figure. So I'm just keeping a bunch of extra significant figures. We can round it off at the end when we have our final answer. So this is the velocity the plane goes. Now to calculate the centripetal acceleration, we're going to have to do this. I'll erase a couple of things here, and we'll write this over here. Okay, I've written this out here. 171.8, that's the velocity. I'm squaring it, just like we had here, divided by the radius that we're going around the curve. So let's calculate this and see what we get. I get 8.99 meters per second squared. I'll write that over here. Always put the units in. If we wanted to take this to one significant figure, assuming this is one significant figure, that would just be 9 meters per second squared. So that could be approximately 9 meters per second squared if we wanted to, which is pretty close to the acceleration of gravity. Gravity is 9.8 meters per second squared downward. So these people in this airplane and the airplane are going to be experiencing this outward force, pushing them against the wall of the plane like that. Remember we talked about that's the centrifugal force. They're going to be feeling this gravity, this artificial gravity, pushing them outward pretty well with the same force that they're being pushed downward by the Earth's gravity. So that's pretty significant, but it's not unreasonable for a plane going around a curve like this. So if that helped you, like and subscribe, and I will see you in the next video. Bye-bye.